Significant figures. So most of the time all of the time when you take measurements, people make guesses. It's very unlikely that what you read off of a certain measuring device is exactly what somebody else may read. It can be different by a very small amount, but there's always a little bit of uncertainty in every single measurement that one does. Measured numbers are the numbers that you obtain when you measure a quantity. This can be height, weight, temperature, etc. And to report the length of an object, for example, you would observe all the values and then most of the time have to make a guess. So if you look at the following measurement here below on this ruler and you see, all right, I want to take the length of this wooden stick. It's in centimeters. And all the big lines represent ones place value. Big lines represent one's place value. Then you have this middle line here that's not as long as the ones. That represents, if you count 1, 2, 3, 4, 5. So middle line represents the 10th because 0.5 is the 10th spot. Okay. Then you still have a smaller marking than that. So that means that your finest marking is to the 10th spot. So if you wanted to record this measuring device with this wooden tool, you would see, all right, I'm right over here somewhere. I'm not exactly at the line. So I would write here 4.1234 or 6, but I don't think that if I write 4.5 or 4.6, I'm missing at the fact that I don't think it's exactly at either of them. So I would say it's 4.59 centimeters. Now, somebody else may say 4.58 or 4.57, and that's where that last digit becomes an estimate. So whenever you take a measurement, you have to record all of your finest markings, meaning any line that indicates a certainty. So that was known. They know that these are in the ones, the tenths, the hundredths, etc. So my 10th spot was the last spot that I knew a marking and some certain value. So these are my two certain values. And then the hundredths right here is my uncertain, where I had to guess. And you always include your one uncertain digit at the end to describe that it is 4.5, but a little bit closer to 4.6, but not exactly yet to 4.6. Every measurement recording includes all certain digits based off of all the markings. And note that markings could be in 2s, in 0.5s, in 0.1s. It can always depend. Plus the one estimation, which will be your uncertainty and the decimal place value after the place value, not decimal place value, I should say, the place value after all your certain. So in our example, we have to the 10th spot here, certain, so the 100th spot was our uncertain. This is something we call significant figures, reporting only what is significant rather than continuing on too many guesses or not giving enough information. These give us everything that's certain plus the one guess, so we're pretty certain about that length, that volume, etc. When just looking at numbers, the rules for significant figures are as follows. A non-zero number is always significant. So let's say 2.5 has two significant figures. Non-zero, just a number. A zero between non-zero digits is also significant. So 202. This is three significant figures. That zero between the twos tells me that it's in 200 since it's important. A zero at the end of a decimal number, meaning 2.0. This decimal, then the 0, tells me that there's no higher or lower. This is exactly 2. So I have 2 significant figures. And the coefficient of a number written in scientific notation. So if I had written 2.0 times 10 to the second, the 10 to the second is ignored. That's not part of the significant figures. What comes in front of it is. So you look at just the number in front, the coefficient, and you see 2.0. You have 2 significant figures. All right. When non-significant, at the beginning of a decimal number, so if you were to see something like this, 0.02, now those zeros, even though there's a decimal, don't really give us any information, so you only have 1 significant figure. Used as a placeholder in a large number without a decimal point. So that would mean if you had 200. These zeros we call them trailing zeros. Don't really indicate any certainty. Is it 200? Is it 2.00? Is it 20.0? So we call this ambiguous and say that they are not significant. You only have 1 significant digit here. And that is the way you go around looking at different significant figures, knowing where the 0 is, whether there's a decimal, if it's trailing or if it's bleeding, and how many significant figures you have in every number that you see.